Hello, in this video, let's talk about continuity at a point. So when we are asked if a function is continuous at a point, the proper definition is the limit as the function approaches that point from both sides must be equal to the height or the value of the function at that same point, which basically in English, in plain English, means that if you could draw the picture without picking up the pencil or the pen, then the function is continuous. And if you cannot do this, if at any point you have to lift off the pencil, then that function is discontinuous at the same point. Here is a picture, and we can apply the definition to each one of these points of interest. So here we have four interesting points: -6, 4, 9, and 12. And so using our simple definition, can we draw this diagram at -6 without lifting the pencil? No, because as soon as we get here, there is a gap in the picture and we have to lift the pencil. And so this function will be discontinuous at -6. Now at 4, can we draw this diagram at 4 without lifting the pencil? Once again, no. Once we get here, we have to pick the pencil and put it here, which means this function is discontinuous at 4. But at 9, we can draw the entire diagram without lifting the pen, which means the function is continuous at 9. And at 12, the function is once again discontinuous because it's impossible to draw this picture and go from this arm to this arm without picking the pencil and putting it here. So the function is discontinuous at 12. A different way to say it is that the limit as we approach some point must exist and be equal to some number. The height at that same point must be equal to that limit number. In other words, as you're getting closer and closer to this point, the height from the left side equals to the height from the right side equals to the height in between, which means you can pretty much step through if you're walking on this path. So here you are, or I am. So here I am, I'm walking, and as I'm getting close to this point, the height is equal to the same as when I'm stepping on the point, and it's the same as I keep going through it. And so there is no discontinuity in the height, which means the function is continuous at this point. And that's all we are trying to say with our definitions. Now let's use the proper definition for each one of our 4 points and write why the function is continuous or discontinuous. We already know the answer because we can visually see where the picture makes a break. And where the picture makes a break, that's a place where the function is discontinuous. But to earn the credit, we have to justify our answer. So let's answer these 4 questions. Is the function continuous at each one of these points? So how about at -6? So what happens at -6? At -6, we have, as we approach -6, from the left side, the limit as x approaches -6 from the left side is equal to 4. From the right side, the limit as x approaches -6 from the right side is also, from this side, is also equal to 4. But what is the value at -6? So the height at -6, what is that number? Well, at -6, there is a gap, and the height is not 4, the height is actually 6. Now the question is the function continuous? Well, the limit from both sides, the limit is equal to 4. So this number exists and it equals to 4. But does it equal to the number of the height? This number is 4, this number is 6. No, they are different, and so this function is discontinuous, is not continuous at x equals 6, negative 6. So that's our answer, not continuous. How about 4? So as we approach 4, what do we see? Well, we see that the limit from the, as x approaches 4, from the left side is equal to 2, but from the right side is equal to 4, which means the limit from both sides does not exist. And if the limit here does not exist, if this number is impossible, then of course it cannot be equal to the height. So in this situation, the function is once again not continuous at x is 4. Now what about 9? Well, at 9 everything looks good, because at 9 the limit as x approaches 9 from both sides is equal to the height, which is equal to 1. And the value at 9 is also equal to 1. So as we approach 1 from the left and from the right, as we approach 9 from the left and from the right, the height is equal to 1. And as we step on the point, the height is also 1, which means the function is continuous at x is 9. And the last one at 12, let's look at the diagram here. We have limit as x approaches 12. From the left side is infinity. From the right side is also plus infinity. But what is the height as we get to 12? Well, the height, not the limit, the actual height as x is equal to 12, what is that number? Well, that actually does not exist, because we have a vertical asymptote and there is no point, there is no height right in there. So that means these two are not the same. So once again, the function is not continuous at x is 12. And that's what we mean by the continuity at a point. If you have any questions on anything, please let me know. If you like anything, give it a thumbs up. If you don't like anything, give it a thumbs down. If you have any comments or anything I can change or improve, if you have any questions on any topics that are similar or different, please send me a note and I'll do my best to answer those questions as well. If you like anything or find this information useful, please feel free to share it with your friends on your social media sites. Thanks again for your time. Take care.